Okay, so we are doing another angle addition, an angle proof. So what I would do is copy down the given and the proof, the diagram, nice neat diagram, statements and reasons. So I would pause the video and then continue. Make sure you get all that copied down all nice and neat. So I'm going to start off with my given. So I know then that the measure of angle 1 equals the measure of angle 3. Again, the first reason is always given. I'm going to make sure I mark that in my diagram. Angle 1 equals angle 3. Okay, so I'm kind of stuck. So I'm going to look at my proof. EBA. I'm trying to prove, so I can't mark it on my diagram because I don't know it for a fact though. I'm going to do it in pencil. I'm looking for EBA, that whole angle, equaling or being congruent to DBC, which is that angle. So in a previous video with segment addition postulate, notice that both angles have this piece in there. So this would be that overlap I talked about. We're probably going to want to be subtracting something eventually or minusing something. I also said that if you're dealing with angles or segments and you have more than one, you're probably going to use either the segment addition postulate or the angle addition postulate. So I am going to use the angle addition postulate for CBD. Now notice I just said CBD, but here it says DBC. Do not use both of them. So whatever is in your proof, that's what you need to be using. So angle CBE, so the measure of angle, I'm going to make this easier on myself, and I'm going to use angle 1. So angle 1 plus the measure of angle 2 equals angle, I would want to say CBD, but that's not what I have here. So DBC, be consistent. Measure of angle DBC because of the segment addition postulate. Nope. Angle addition postulate, very common error. We're dealing with angles, not segments. Angle addition postulate. And I'm going to use the angle addition postulate again to get those pieces involved. So I know that the measure of angle 2 plus the measure of angle 3 equals, I want to say EBA. I want to make sure that it's the same. Yep, so it's EBA. I want to keep it consistent. And that would also be the angle addition postulate. Okay, so somehow we have to get these two angles or these two segments to merge together. So I have number 4. I don't know exactly what I'm doing yet. I know that 1 is congruent to 3. So anywhere I see a 1, I'm going to put a 3 or vice versa. It does not matter. So I have angle 1. I'm going to put an angle 3 in here. So I'm going to substitute those. So the measure of angle 3 plus the measure of angle 2 equals the measure of angle DBC. So this is just substitution. And that would be putting the idea of 1 into 2. Okay, let's see what this gives me. Okay, so I'm kind of seeing something here. Something's going on here. I'm going to use a property that isn't used very often, and that is just simply switching places of these two. So the measure of angle 3 plus the measure of angle 2 still equals the measure of angle EBA. Now this is a property that you use a lot probably in elementary. All this is saying is that if you have 3 plus 4, that is the same thing as 4 plus 3. So this is actually using the commutative property of addition. So it's just changing the order of the numbers. Okay, commutative property of addition. So now I want you to focus on this. Aren't these exactly the same? So if these are exactly the same, that means I can set these equal to each other. So the measure of angle DBC should equal the measure of angle EBA by either substitution or transitive. It's not going to matter. I'm using 4 and 5, so that idea. We'll see if this matches exactly what I'm trying to prove. And that'd be no. So I have EBA on the left. Well, right now I have EBA on the right. So I need to do a little switcheroo and have the measure of angle EBA equals the measure of angle DBC. I'm going to extend my graph a little bit. So what property says that I can take all my stuff on the right and put it on the left and vice versa? That would be the symmetric property. And I'm going to check again. Is my last last statement, does it match my proof? That is also a no. Notice here I have a congruency symbol. Here I have an equal symbol. So I know that I can just simply say that the angle EBA is congruent to angle DBC. So what property do we have that says, hey, I can just change it from the equal to the congruency symbol? And that would be the definition of congruent. Now, does my last statement match my prove exactly? And that would be a yes. So I am done. Put my 3 dots in a triangle, meaning therefore I have proven this. So kind of going back, if you have this piece and this piece, so in other words, we have this overlap, and this is the same thing for segments or for angles, you're going to end up having to subtract those from each side, or going to have to use some substitution of some sort to get those two statements, to get these two statements together. Okay?